Okay, this is a think, pair, share. So this is a problem um, that you, the student, should work on first. And if you get stuck on any part of the process, or if you just want to hear my interpretation of my solution to this, feel free to continue watching this video. Otherwise, you can pause here and resume. Okay, so two types of medication for hives are being tested to determine if there is a difference in the proportion of adult patients' reactions. Test at a 1% significance level. So 20 out of a first random sample of 200 adults given medication A still had hives 30 minutes after taking medication A. 12 out of a second random sample of 200 adults given medication B still have hives 30 minutes after taking medication B. Okay, so this one you have to be really kind of careful. So let's look at our givens here. And the first thing to really kind of try and interpret is what are we going to consider a success? And a success, I think, would help if it was something that felt intuitive to us. So let's say you have hives and, it's really uncomfortable, okay, to have hives, and you want to go to the local drugstore or the grocery store and get a medication to alleviate it, or maybe go to your doctor and get a prescription. You want to go there to get rid of it, and you want it to get rid, you want to get rid of the symptoms fast in under 30 minutes. So I would consider that a success, that whatever medication you take, the hive symptoms are gone in under 30 minutes. Okay, so we're going to say that the medication maybe eliminates symptoms in less than 30 minutes. Well, the reason why it's important to define what we are going to consider as success is we have to maybe then interpret the values that we've been given um, to see if it fits in with our definition of success. So if we look at this first medication, medication A, so let's do medication A. It says 20 out of 200 given medication A still had hives 30 minutes after taking medication A. So what this looks like to me is this looks like a bunch of failures, right? So, if we were to consider that we were given a proportion, or maybe not necessarily a proportion. Let's see here. Well, let's see. The proportion of failures for medication. Oh my goodness, why is it doing that? Okay. Let's see here. Proportion of failures from population A. Okay, so we would maybe say that that's going to be okay, the number of failures over the sample size. So this would be the number of failures over the sample size. All right, and the number of failures that we had was 20 out of 200. Okay, and that would give us like a proportion of failures here. But what we need is we need a proportion of successes. So we need a number of successes over sample size. Now the sample size isn't going to change. That's still 200. All right. But um, the number of successes plus the number of failures, need to make that a y. Okay, I apologize. My computer is acting slow. There we go. Okay, so the number of successes plus the number of failures should equal 200. And so we know that oh my goodness, needs to be an A. Okay, so we know the number of failures is 20. And so if we subtract 20 from both sides, we can calculate that the number of successes is 180. All right, and that is going to be our x1, n1 when it comes time to put that into our calculator function. All right, let's consider, okay, and we're going to write medication A as population 1. So the population of medication A, we're going to say that that's population 1. All right. Just because we can't use letters in our calculator. All right. So I'm using these numbers that the calculator uses to kind of keep things straight. Okay, now let's look at medication B. Okay, and likewise, right, you still have hives after 30 minutes. So we're actually looking at failures first. And so the number of failures, we'll just rewrite it over sample size, was, let's see, number of failures was 12 out of 200. Okay, and the number of successes plus the number of failures was 200. The number of failures is 12. So we'll subtract 12 from both sides. And so the number of successes for medication B is going to be 188. So if we look at the sample proportion of medication B, the number of successes over sample size, that would be 188 over 200. And we're going to label that X2, N2. Okay. And let's see here. My tablet will let me scroll down. Apologize for the delays. Just doing the best I can here. All right, so the population proportion for medication B, we're going to label that P2, for reference um, of the calculator here. All right, so we've got all of that. What else were we given? Okay, so we were told a significance level of 1%. Okay, so we have a significance level of 1%. which means we're going to have a confidence level 1%. I need to put 0.01. Would be 0.99. And then if we took this significance level and divided it by 2, that's going to give us 0.005. I hope you realize like I caught myself in a mistake. It's really easy just to kind of get yourself, going, without thinking about what you're doing. And I had translated 1% to be that. But because I wrote down the confidence level, I thought, well, zero point 0.1 plus 0.99, that's not going to be equal to 100 or 1. I got that wrong. Okay, so that's part of the reason why it helps to write all this stuff down. Okay, now we need to figure out what our original claim is too. So what's our original claim? Two types of medication for hives are being tested to determine if there is a difference. If there is a difference. So we're going to interpret that as being not equal to, right? If there is a difference, they're not equal to each other. So the population proportion of successes is different from the population of proportion of successes in the other medication. And that is our original claim. Okay, which looks like that's the alternate hypothesis. All right. Oh my goodness. I know, maybe this is frustrating you, but this is frustrating me as well. We will just roll with it. Okay. Step 2 is to set up our null and alternate hypothesis. So let's write down our original claim first. Okay, now we'll write down the complement. And the null always has equality. And so the other one has to be the alternate. And the alternate, the inequality in the alternate hypothesis tells us, the shape of our distribution here. Not really the shape, but what tail we're going to be considering. So this is going to be a two-tailed distribution. All right, that's everything we're going to get out of that step. Step 3 is to calculate our test statistic and our p-value from the sample data. All right, so because this is a think, pair, share, notice that there's no calculator screenshots. So hopefully you were able to do this from memory. So in the Texas Instruments, we want to go to Stat, Tests, and we're doing a two proportion z-test. Okay, and so in sample 1, we have 180 successes out of 200. And in sample 2, we have 188 successes out of 200. And the alternate hypothesis is not equal to. Okay, I'm going to leave that up because I want to do the same thing now in the NumWorks calculator. So I'm going to go to the Inference app, go to Tests, two proportions. We're going to do a two proportion z-test. All right. The null is equal. The alternate is not equal. So good there. Okay, so number of successes is 180 out of a sample size of 200. Success here is going to be 188 for the second sample. That's out of 200. And now we have a significance level of 0.01, 1%. So I'm going to hit next. All right. So there's our test statistic and p-value. Let's kind of corroborate that with the Texas Instruments. So we have negative 1.47 with a p-value of 0.14. All right. So let's go ahead and write that down. So we have a z test statistic of negative 1.47 with a p-value of 0. Was that 140? Yeah, 140. All right, good. So now let's go ahead and copy that over here to the next page. I mean, you don't have to do this so much because you have a physical page in front of you, but I'm doing this digitally, so um, and I'm having trouble scrolling here, so I need to write it at the top. Okay. Again, frustration, serenity now. All right. So step 4 is to sketch our distribution. So we're going to draw a normal distribution, which has a center of 0. Okay, the alternate hypothesis told us that we have a two-tailed distribution like that. So we're going to have a positive z critical value and a negative z critical value. Our alpha over 2 was 0.005 if memory is correct. And because this is two-tailed, it's going to be on both sides. Okay. With a confidence level of 0.99. Okay, the region over the tails, that's the reject the null. And the region between the two critical values is the fail to reject the null region. All right, we have our test statistic. We don't have our critical value yet. So we are going to have to use an inverse distribution function to convert the area of 0.005 or 99.99 into our critical values. All right, so let's go ahead and do that. So I'll do this one just a little bit differently than I did last time. So let me go to the distribution functions. Again, go to inverse norm. And I'm going to do the area on the right. So I could do center again, but I'm just going to change it up just to show you different ways of calculating the same thing. Okay, area to the right. Okay, let's do the same thing with numworks. So I'm going to back out of this. And I want to go to the distributions app. Normal, 0 and 1. Okay, and I'm going to do the same thing where I want the area to the right. And that area is 0.005. All right, so we get 2.576. Yep, 2.576. So we're going to have a positive 2.576 and a negative 2.576. All right. Now that we know where our boundaries are, let's see where our sample uh, test statistic falls relative to this. So we have a negative 1.47. So it looks like negative 1.47 is going to land between 0 and our critical value. So it's going to be, just to make it easy, I'm just going to say it's right here. It's somewhere between 0 and negative 2.576. So right here is our Z test statistic of negative 1.47. And if I draw straight up from that, that's clearly indicating that we're going to fail to reject the null. Okay, and now we've got this area here. This is our p-value. And our p-value was pretty big, 0.140. Remember, if p is smaller, reject the nuller, right? Well, our p-value is not smaller. So we're not going to reject the null. And in fact, then we have to fail to reject the null. So if we compare number line values to number line values, it's telling us to fail to reject. And if we compare area to area, that too is telling us that we're going to fail to reject. All right. So I'm just trying to change my pen color back to black. Serenity now. Okay. And now we're ready for step 5, which is now to kind of culminate our results and write our conclusion. So our result here is to fail to reject the null. And let's see, what was our original claim? Our original claim was the alternate hypothesis that there's no difference. Yeah, it did it again. Okay. So let's see, fail to reject the null. Let me clean this up a little bit. Okay. All right. And the alternate hypothesis was our original claim. So that means down here on our conclusion table, oh my goodness. All right, we've got fail to reject the null, and the alternate is our original claim. So this is going to be our outcome. There is not sufficient evidence to support the claim that. All right, so let's just start writing it out. There is not sufficient evidence to support the claim. That there is a significant difference. I realized I didn't put the word significant, I think, in the last example, but that's okay. But there is a significant difference in the proportions of adults who did react in less than 30 minutes to medication A and medication B. And then we're going to say My goodness, what are you doing? With a 99% confidence level. Okay. All right. So this concludes this example. Let me know if you have any questions.